The first application of integration that we want to look at deals with finding the area between two curves. So before we talk about that application, let's talk about how we calculate the area bounded between two curves. In the graph presented, we have the function f of x equals x squared plus 4, and we have the function x minus 1, that quantity cubed, plus 2, as our functions f of x and g of x. If we consider two x values, say x equals 1 and x equals 2, then we could calculate the definite integral of this function f of x as x goes from 1 to 2, or between x equals 1 and x equals 2, and that result would be the region between the graph of f of x and the x-axis. So this shaded region. We could also look at calculating the integral from x equals 1 to 2 of g of x dx, and that result would be the area between the curve in green, or our function g of x, and the x-axis. What this suggests is that we can also find just the area between f of x and g of x, and we could do that by calculating the total area below the function f of x and then subtracting out the area below the function g of x. And we could do that by finding the definite integral as x goes from 1 to 2 of f of x minus g of x. dx. So again, what we're doing here is finding that total area under the curve f of x, then subtracting out the total area under the curve g of x, which leaves us with just that bounded area between those two functions. And then in example 1, we can go ahead and use Symbolab to calculate this result. The first thing that we'll need to do is find the definite integral tab, or tile. This will set up an integration problem for us. We'll input the lower and upper bounds, and then the function that we want to integrate. In this case, it's x squared plus 4 minus x minus 1 to the third power plus 2. We need to make sure we're careful with all of those parentheses so that that subtraction symbol in the middle will carry through to the x minus 1 cubed term and the 2 term. But if we set that up right, we'll end up with the result of 49/12, or approximately 4.0833.